Okay, undefined points. Undefined points come from terms that get canceled out. So here's an example, x squared minus 4 over x minus 2. The first thing you should realize is that this is not factored down to single-powered x. You know, like x minus 4 would be completely factored, but x squared minus 4, it's not factored. It's not down to x to the first power. Like if this was x minus 2, that quantity squared, that's okay. That means x minus 2 times another x minus 2. But this is a quadratic, so that needs factored. Now you can factor these either on the poly sheet, right over here on the right-hand side. You can put in the terms, the coefficients, and it will factor it, x plus 2, x minus 2. Or hopefully you already know how to factor, and you can factor it yourself. So anyway, let's get to it here. So this right here factors into x plus 2, x minus 2, and on the bottom, x minus 2. Here's the big deal. The x minus 2's cancel out, so you just get f of x equals x plus 2. Now, this is basically the graph, except there's going to be a hole in the graph at the value that makes that factor equal to 0. Well, the factor that got crossed off was x minus 2. What makes that equal to 0? 2, because x minus 2 equals 0, and you solve it, and you get x equals 2. So to get the undefined point, you set the factor that's been canceled out equal to 0, and you solve it. That's 2. That's the x part of the undefined point. To get the y part of the undefined point, you substitute that into the factored form of it. So put the 2 in here, and I get 4. So 2, 4, there's an infinitesimally small hole in the graph at 2, 4. It looks like a linear equation, except there's a hole in the graph at 2, 4. So that's like if somebody says, what's the limit as x approaches 2 for this? A lot of people don't think about factoring it. If you put 2 in here, if you're asked, you know, what's the limit as x approaches 2? If you put 2 in this, you get 2 squared minus 4, which is 0. And put 2 on the bottom, you get 0. Well, 0 divided by 0 means that you got something that needs factored. So factor it, cancel off the term, and then substitute it in 2/4. It's as easy as that. How about undefined points for this one? Look, that's not factored. Factor this thing. It breaks into x minus 2 and another x minus 2. Or another way of saying, well, x minus 2 squared. But this x minus 2 on the top cross off with one of these, so I get up with 1 over x minus 2. Now that it's simplified, now is the point where you check what's going on with this thing. So if it says what's the limit as x approaches 2, put 2 into the simplified version of it. Well, if I put 2 into the simplified version, I get 1 divided by 0. In other words, it makes the denominator 0 but not the numerator. Well, how do you find vertical asymptotes? You set the denominator equals 0. If you set the denominator equals 0, you get 2. So at 2, what's going on? A vertical asymptote, not an undefined point. Because even though we canceled it out, which maybe makes you think it's an undefined point, one of them remained in the denominator in which there is a vertical asymptote. So I'll tell you what, I'll graph these two. Let's graph this one right here. I can graph it on Excel. Let's do this one, x squared minus 4 over x minus 2. So on the rational sheet, the first coefficient was a quadratic term, and here's the coefficients going across on the rational sheet. The square term b1 is a 1x squared, and then there was no linear term, and there was a minus 4. So we got x squared minus 4, and then on the denominator, I think we had an x and a minus 2. I believe that was everything. So if you look at this graph, I got it looking here from 0 to 4. If you set your range there, you see that it is two separate graphs. And right here, where they come together, there's actually a microscopic hole where these two are pointing to each other. What's the coordinate for that? 2, 4. There's a hole there, not a vertical asymptote. You can tell because it isn't going off to infinity there. So that's what we're talking about with a hole. Sometimes that hole doesn't show up, so you have to know how to find it by factoring and canceling out. Now the second one, this one here, x minus 2 over x squared minus 4x plus 4, let me put those coefficients in. X minus 2, so that's a 1 and a minus 2 there. And then over here is a x squared, I think it was minus 4x plus 4. So putting that in, what's going on at positive 2 right here? Well, you can see it. There's a vertical asymptote going, gigantic in that section. So it's heading off, actually on one side it's heading off to positive infinity, on the other side it's heading off to negative infinity. But if you're just dealing with a fill in the blank type of question, the answer is infinity. So that one's approaching infinity. Let's take a look at that here. So So it's heading off to infinity for this one right here. Okay. Now this one is a different. Okay, here this one. So there's a vertical asymptote here at x equals 2. That's what's going on. So it's heading off to infinity. This one, the 2's cross off, the x minus 2's cancel off. There's still an x minus 2 on the top. So now when you substitute the value in question, which is 2, in here, you get 0. So there's an undefined point at 2, 0. Okay, this one. Why? Because there's not a leftover x minus 2 in the denominator when you simplify that. And we'll get to rational functions that need simplified in the next video.